You're watching the Weiss channel. Today we're going to simplify radicals with variables inside as well as numbers. For example, what's the square root of x squared? The square root of x squared is x, right? Because x times x is x squared. What's the square root of y to the 8th? The square root of y to the 8th is y to the 4th. So what we're doing with exponents is we just divide by 2 when you take the square root. Okay. So for example, what's the square root of a to the 4th, b to the 10th? That's going to be a to the 2nd, b to the 5th. Now, if I have an odd numbered exponent, all right, I can't take the square root of m to the 7th. So I can take the square root of m to the 6th. So what I'm going to do is I'm going to take 1 away, and instead of m to the 7th, I make it m to the 6th, and I have another square root with just m to the 1. Okay. When I have n to the 9th, I make it n to the 8th, and I have another n over here to make n to the 9th. Okay. Now I can say, what's the square root of m to the 6th, n to the 8th? Well, that's m to the 3rd, n to the 4th, and I've got square root of mn, and that's called simplified. Okay. Now you add in the numbers, okay? Square root of 48, all right? You gotta remember, what perfect square evenly goes into 48? Well, 16 goes into 48. 16 goes into 48 3 times. So we got 16 and 3. Okay. Now I can't do square root of x to the 11th, so I do x to the 10th, and I put an x over there. Can't take square root of y to the 15th, so I do y to the 14th, and I put a y over there. Now I say, what's the square root of 16? X to the 10th, y to the 14th. That's 4, x to the 5th, y to the 7th, and I'm left with that 3xy in the square root. That's how you simplify. Okay. What perfect square goes into 63? 9 times 7. G to the 8th is a perfect square because that's even. H to the 5th, however, I got to make h to the 4th times h. Okay. So now what's the square root of 9? G to the 8th, h to the 4th. That's 3 g to the 4th, h to the 2nd with the square root of 7h. And that's simplified. Now, there will be some problems where you have some mess on the outside. We're going to ignore that to begin with. We're just going to write it down and ignore it. But we're going to take the square root of 50 and say, what perfect square goes into 50? Well, that's 25 times 2. P to the 4th, I'm just going to leave it, P to the 4th. Q to the 7th, I can't take the square root of q to the 7th, but I can take the square root of q to the 6th times q. So now, once again, I still ignore this 3p to the 2nd, q to the 5th. Just rewrite it. Okay? And now I say, what's the square root of 25? That's 5. Square root of p to the 4th, q to the 6th is p to the 2nd, q to the 3rd with the square root of 2q. Now I'm going to deal with this 3 and the p to the squared q to the 5th. 3 times 5 is 15. P to the 2nd times p to the 2nd is p to the 4th. Q to the 5th times q to the 3rd is q to the 8th with the square root of 2q. That's what you do. Okay? This 4, j to the 3rd, k to the 4th, ignore it, just write it down. But what perfect square goes into 18? 9 times 2. J to the 6th, that's a perfect square, just rewrite it down. K to the 3rd, I can't take the square root of that, but I can take the square root of k to the 2nd, so I bring a k over there. Okay. So now, once again, I rewrite 4j to the 3rd, k to the 4th. I ignore that for now. And I say, what's the square root of 9? J to the 6th, k to the 2nd. That's 3j to the 3rd, k. with the square root of 2k. Now what's 4 times 3? 12. J to the third times j to the third is j to the sixth. K to the fourth times k is k to the fifth with the square root of 2k. You've been watching the Weiss channel.